Follow the link in the video description. In this lab, we will do some basic STP configuration. STP runs by default, so you don't actually have to configure it. However, if you just leave it at the default settings, there's no guarantee that traffic will be following the optimal path. So it's a good idea to explicitly configure which switch should be the route for each VLAN, and also set different routes for different VLANs. So each VLAN uses different links, balancing the load of the network. Step 1 in this video is to use the CLI to check the current STP topology, identify the route bridge, and the STP role and state of each port on each switch. I'll start on switch 1. First, let's get into privileged exec mode. Enable. We only need one show command. Show spanning tree. Information is displayed separately for VLAN 1 and VLAN 2. However, because I haven't done any configuration yet, their settings will be the same. Same route bridge, and the role of each port will be the same. So let's just look at VLAN 1. Which one is not the route bridge? Notice the MAC address is different in the route ID section and the bridge ID section. As for the port roles, you can see them here. X03 is the route, so I'm guessing switch 2 is the route bridge. Let's go on switch 2 now to check if that is the case. First, enter privileged exec mode. Enable show spanning tree. In the route ID section, it clearly states this bridge is the route. You can also see that all of its interfaces are designated ports in the forwarding state. This is the case for both VLAN 1 and VLAN 2. Without any specific configuration, each VLAN will have the same route, and the port roles will be the same in each VLAN. Next, let's go on switch 3. We know it's not the route, but which port do you think is the route port? It should be X02. Because it's direct, do you think is the root port? It should be X02, because it's directly connected. And all of these connections are fast Ethernet. There are no gigabit Ethernet at a lower cost. Enable show spanning tree. Indeed, X02 is the root port and spanning tree. Indeed, X02 is the root port and X01 is designated. Finally, let's check switch 4. 01 is designated. Finally, let's check switch 4. Its X01 interface should be the root. Enable show spanning tree. As expected, F01 is the root port. Also, F02 is blocking. The role says alternate. This means a non-designated. Step 2 is to configure load balancing by making switch 1 the primary route for VLAN 1 and secondary route for VLAN 2, and the opposite on switch 2. Let's return to switch 1. Go to global config mode, cont T. Let's configure it as the route for VLAN 1. Spanning tree VLAN 1, route primary. Remember to include the VLAN in the command. In Cisco's PVST+, all configurations are done on a per VLAN basis. Next, the secondary route for VLAN 2. Spanning tree VLAN 2, route secondary. Now I'll hop onto switch 2. Off T, spanning tree VLAN 1, route secondary. VLAN 2, route primary. Okay, that's it. So what is the STP role and state of each port now? Well, here on switch 2, in VLAN 2, all ports should be designated. But now on switch 1, X03 should be the root port now. Well, here on switch 2, in VLAN 2, all ports should be designated. But now on switch 1, X03 should be the root port, because it's directly connected to the new route, switch 1. Let's check. Do show spanning. So for VLAN 2, it is still the root. But for VLAN 1, X03 is now the root port, as expected. Designated ports in a forwarding state. Let's go back and check on switch 1. In VLAN 1, all ports should be designated, but in VLAN 2, X03 should still be the root port, like before. Do show spanning tree. So indeed, in VLAN 2, X03 is the root port. X01 and X02 are designated. In VLAN 1, however, switch 1 is now the root bridge, so all ports are designated. In step 3 and 4, we are going to manipulate a couple STP port settings and see the effects. First up, we will increase the cost of switch 4's X02 interface 100 in VLAN 1 and see if it selects a different root port. First, let's confirm that the current root port is X02. It should be for VLAN 1. Let's view the spanning tree for VLAN 1 only. Show spanning tree VLAN 1. Okay, as expected, X02 is the root port. It has the lowest cost to switch 1, the root. Let's change that cost. Before doing so, what do you think will happen? What is the first criteria in selecting the root port? It's the cost. So increasing the cost to over 5 times the current cost should cause switch port to select a different root. Let's try. The configuration is done from interface config mode, so interface x02. Spanning tree VLAN 1, cost 100. Now let's view the spanning tree just for VLAN 1. Do show spanning tree VLAN 1. Okay, as expected, x02 is no longer the root VLAN 1. VLAN 1 again. Do show spanning tree VLAN 1. Okay, as expected, x02 is no longer the root port. It is changed to a blocking state. Now x01 is the root. Step 4, we will increase the priority of switch 1's x01 to 240, the highest possible priority number. Oh. However, in STP, a lower number is actually treated with higher priority. So really, we are lowering the priority to 240, even though the number itself is greater. Will this affect switch 3's selection of a root port? First up, let's check switch 3's root port for VLAN 1. It should be F01. Let's just view VLAN 1 again. Of a root port. Lowering the priority. TP, a lower number, is actually treated with higher priority. So really, we are lowering the priority to 240, even though the number itself is greater. Will this affect switch 3's selection of a root port? First up, let's check switch 3's root port for VLAN 1. It should be F01. Let's just view VLAN 1 again. Do show spanning tree VLAN 1. Indeed, X01 is the root port. Now, if we set the priority of switch 1's X01 port to 240, will this affect switch 3's root port selection? What do you think? Will this affect switch 3's root port selection? What do you think? Actually, it shouldn't. Sender port ID is actually the last tiebreaker, after port cost and sender bridge ID. Because X01 has a lower root cost than X02, 19 versus 38, the port priority should have no effect. Let's go configure that port priority on switch 1. Priority shouldn't. 01 port to 240. Will this affect switch 3's root port selection? What do you think? Actually, it shouldn't. Sender port ID is actually the last tiebreaker. After port cost and sender bridge ID. Because X01 has a lower root cost than X02, 19 versus 38, the port priority should have no effect. Let's go configure that port priority on switch 1. Enter interface config mode, interface X01. Spanning tree VLAN 1, port priority 240. First up, let's view that priority here on switch. Do show spanning tree VLAN 1. Here for interface X01, you can see the priority.number column. This is the port ID, and the priority has increased to 240. Now let's check on switch 3. Use the up arrow to return to the previous command and hit enter. As expected, there is no change. X01 is still the root port. Finally, let's configure portfast and BPDU guard. Before doing so, let's test portfast. I will turn on link lights for this. Click Options, Preferences, and then Show Link Lights here. Next, let me delete the connection between switch 3 and PC1. Now I will connect them again between switch 3 and lights here. Next, let me delete the connection between switch 3 and PC1. Now I will connect them again, PC1 to switch 3's X03 interface. Connect them again, PC1 to switch 3's X03 interface. After reconnecting the two devices, switch 3's X03 interface has to go through the STP listening and learning states before it can forward. Let's go on the CLI and configure both portfast and BPDU guard on X03. Interface X03. Spanning tree portfast. Spanning tree BPDU guard enabled. Okay, that's it. Pretty simple configuration. Now that portfast is enabled, I will delete that connect before it can forward traffic again. So the link light will remain orange for about 30 seconds. Let's go on the CLI and configure both portfast and BPDU guard on X03. Interface X03. Spanning tree port. Spanning tree BPDU. Guard enabled. Okay, that's it. Pretty simple configuration. Let's reconnect them again. PC1 to switch 3's X03. Notice that it moves immediately to guard is enabled if we convene right away. Now, because BPDU guard is enabled, if we connect X03 to another switch and a BPDU is received, the interface should be shut down. Let's try that. I'll delete the connection once. And this time, let's use a crossover cable to connect X03 to switch 4. When switch 3 receives a BPDU from switch 4 on its X03 interface, the interface is shut down to avoid a loop. Now the link light is red. Let's delete that connection and use a regular straight-through cable to connect to PC1. Now let's return to the CLI, and to enable this interface that was disabled by BPDU guard, I will shut down, then no shut down the interface. Okay, now X03 is back up and running. Okay, since we finished our experiment, I'll just configure the same on switch 4. Finished class. Bandentry deep tech from Medicine for Encore. This is a CCNP CCNA exam topic. However, what we're going to look at is here, I'm going to click on Load Lab, but I've already done that. So this is the lab. Create a BTP management domain for distribution of VLANs to all switches, and configure a primary and secondary root bridge for the VLANs in the network. So this is definitely a CCNP level lab. It's quite challenging, quite extensive. And it's not just about configuration, but goes and asks you a lot of really good questions to test your understanding of spanning trees. And I think I've said it before, but that's something I really like about NetSim. Not all about the configuration. It really does test your understanding, really help you get ready for the exam. So these are commands you need. Although this is a CCNP level exam, these are actually all commands you already know. So spanning tree, show VLAN, spanning tree VLAN root, spanning tree VLAN priority, switch port mode, isolation.1q. So these are all commands you already know. Although this lab might be a challenge, I think it actually is doable for someone studying for their C. So I'm not actually going to do the configurations in this demonstration. One is perform the initial configuration. It helps you review so how is this information cleared. What's ready? Question. Want to leave a tip? Check the links in the description.
啊，讲赢了嘛，背过心理黑暗。
Package tracer is one of the greatest tools ever made. But
He's like, what do you want? Water faithful? Go. Go, Jack. What is this? Yeah, go, Frank. It's from. Go. I don't want it. Yeah, let's just not. Yeah, let's just not do it. Let's just not do it. How's that sound? Do it. Okay. At the end, I was slapping. Put him to the very end.
that's okay too.
Move it again. Buddy, there is nobody on this planet that knew this. Okay. And so, all this buddy, you don't have to the group everything. And so, I'll get it. Right here. Yeah. Oh, come on. To be me. Who I am. Not who you want me to be. Yes, I'm different, and that's what I want you to see.
Yo, everyone, I want you to try this. And think of it like this. Look at it one eye and the other eye. Like that.
Your cheeks glow.
You are capping so hard it could be a crime. Shut up, lying. Shut up, lying. You are lying so unbelievably bad, but stop it. You are lying. I'll save her? Oh, buddy, you're worse. Oh, dude. This is you? Who's this? I'll save you. Oh, chat. Y'all are actually on. Y'all are actually. Oh, chat. This is for. Chat, this is.
And that's so period.
Oh, I need you, love, for the summer, and I'm sure that every day you'll get better.
New country two. Do what me? You are the blue line. Yes, I did. I'm playing the young version of that Nick
Who?
It sure is.
What the hell are you talking about? Well, I think I love you.
Mess up and everyone would have to fucking go away from this life. So I'm here for me, not anyone you want me to be. I'm here for me, not you. But to be honest, you was never here for me. When I needed you there, you always want to push me down when you don't even know
You ain't getting pushed out.
what I've been through. You were everywhere, but not where you need.
Text me at all. That's why we're gonna call. I'd rather see you and have a ball. That's true. But we ain't got no time at all. Oh.
Really actually planning on that I ain't gonna make it. That I'm not gonna make it. Oh man. Diabetes. Down, bro. Calm down. Calm down. Whoa. Whoa. Vision blurry. Okay. Got a vision. Yeah, mostly finished. It feels like it's been 7 minutes, Chad, but it feels like eternity. Yeah, it's been 7 minutes, but it feels like an eternity.
After giving it careful thought,
For this function, we have this our system information, like types and numbers and all of that stuff, and I just checked and we have here 100. A lot of those are not. We have animals, demons, elves, fairies, ghosts, goblins, gods, hybrids, which are like, an animal and human together, robots, sea monsters, angels, aliens, and skeletons. So, there you go, those are our non-human. Like, I don't know if I said it yet, but there's around a lot.
What if we pack this? You can't get carried like this. Now you're lost.
Yeah, I would feel like when it's gone. Maybe I'm too much, no. Maybe you never get it.
Bro, people really think they're in an edit sometimes. That people really be thinking they're in an edit, dude. They really be thinking they're in an edit. We're almost there. Yeah, we're almost there. Stop it, Joe. Who's this? We're almost there.
When he's dating your ex and thinks they hit the jackpot.
Looking for. Oh, you're in the video.
Okay, what's up, guys? I'm gonna get Devin to dare him to read that.
Did you tell him what he mixed? You don't know what he mixed with me?
We mix this,
Okay, Devin.
Arclay
And pineapple coconut.
Yeah.
Oh, you're such a,
My
you're
own
such a
intimate
risk
doing
taker, Devin.
Ready?
Yeah,
One. I think two.
two, great.
Wow, Devin, you're such a risk taker, buddy. Yo, he slammed it up. Oh,
All right, stop it.
God. Whoa, 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 whoa. Whoa, 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 whoa. Nothing happened.
I know how to dance. Keep your lip pushing like a hill with the fans. Running your shorty, she counting my band. Eating like a big guy. Shorty, give me the big.
Like one sentence.
You do one sentence or less. There's nothing less than one.
Oh, oh.
Come back, look.
It's our fun supposed to order and tell tales of battles and conquer. Huzzah!
Habataita, modern, necessita.
Huzzah!
Habataita, modern, necessita.
But should I not you respect thee? I collect only what is due, shout. Is wrong. You defend your clan. You bet.
Yes, just ignore what I say by the end of the day. You messed up. I don't know what to say. What do you want to do? Like, very bad.
Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. In this video, we will continue our study of span entry, focusing instead on an updated version called rapid span. More specifically, we'll be looking at Cisco's version, rapid per VLAN spanning tree. You saw in the previous lecture that classic spanning tree can be quite slow, taking up to 50 seconds for the network to converge after a change in the topology. As the name implies, rapid spanning tree improves this time, only taking a few seconds to respond to changes in the network. Because rapid spanning tree is superior to classic spanning, it is the default on most devices now, and the CCNA exam topics only mention rapid spanning. However, I think it is important to understand classic spanning. And now that you know about classic spanning tree, rapid spanning tree will be much easier to learn. Let's take a look at what we'll cover in this video. First up, let's take a few minutes to compare different versions of STP. In the past few videos, I've mentioned multiple versions: STP, PVST+, rapid STP, rapid PVST+, multiple spanning tree. Just so there is no confusion, I will summarize each version and clarify between the industry standards and the Cisco proprietary versions. Then the rest of the video will be all about rapid spanning tree, specifically the version which operates on Cisco switches, rapid per VLAN spanning tree plus. Also, make sure to watch until the end of today's quiz. I will once again feature a bonus question from Boson Software's XSIM for the CCNA, set of practice exams for the CCNA, which I highly recommend. Ask anywhere on the internet for CCNA practice exam recommendations, and people are going to recommend Boson. If you want to get a copy of XSIM to prepare for the exam, follow the link in the video description. Let's start by summarizing the different versions of spanning tree. On the left, I will list the industry standard versions, IEEE standards. Right, I will list the Cisco proprietary version, Cisco's upgrades to some of the standard versions. First up, the classic spanning tree protocol, IEEE standard 802.1d. This is the original spanning tree. According to Wikipedia, it was originally published in 1990, although the original spanning tree was actually created in 1985 before being standardized. In classic STP, all VLANs share one STP instance. Therefore, we cannot load balance using classic STP because there is only one instance. We cannot block different ports in each VLAN to achieve load balancing. So Cisco decided to improve upon this. They developed per VLAN spanning tree plus. Actually, before that, they developed regular per VLAN spanning tree, which, as I mentioned before, only supported ISL trunk encapsulation, no .1Q. But let's forget about that version. Everyone uses .1Q for their trunk encapsulation needs. It's Cisco's upgrade to 802.1d. Each VLAN has its own STP instance. In the previous lab, when we configured STP, we had to include the VLAN number in each terminal. For example, spanning tree VLAN 1 root primary. That's because a separate STP instance is running for each VLAN. Why is this good? Well, as you already know, we can load balance by blocking different ports in each VLAN, in each STP instance. We can use our network bandwidth more effectively, since we don't have any connections going totally unused, just waiting for another connection to fail. Now, as you also know, classic spanning tree and PVST Plus are quite slow. The max age timer is 20 seconds, and the listening and learning states are 15 seconds each. So it can take up to 50 seconds to respond to changes in the network. Stage timer is 20 seconds, and the listening and learning states are 15 seconds each. So it can take up to 50 seconds to respond to changes in the network. That's simply not fast enough for a modern network. This was solved in rapid spanning tree, IEEE standard 802.1W. It is much faster at converging and adapting to network changes than 802.1d. However, just like 802.1d, the industry standard rapid spanning tree protocol runs only one STP instance, shared by all VLANs. Therefore, it also cannot load balance. Cisco once again developed an improved version of industry standard, rapid per VLAN spanning tree plus, or rapid PVST. It is Cisco's upgrade to 802.1W, featuring the improved speed of rapid STP, Plus, it runs a separate STP instance for each VLAN. Therefore, it can load balance by blocking different ports in each VLAN, just like the previous PVST. The final version is multiple spanning tree protocol, IEEE standard 802.1. It uses modified RSTP mechanics, but the main improvement is that it can group multiple VLANs into different instances. For example, if there are 10 VLANs, VLANs 1 to 5 in instance 1, and VLANs 6 to 10 in instance 2 to perform load balance. Finally, an industry standard version of STP that allows load balancing, and actually it's superior to Cisco's rapid PVST. If you have many VLANs, let's say 200, configuring primary and secondary root bridges in each VLAN is a lot of work. However, with NST, all you have to do is assign VLANs 1 to 100, instance 1, and VLANs 101 to 200 to instance 2, and then configure the primary and secondary root bridges for instance 1 and instance 2. So it's much easier to configure and manage. Actually, Cisco hasn't developed their own version of NST. Cisco devices simply run the industry standard 802.1. For large networks, it's best to use NST. However, for small to medium networks without a huge number of VLANs, Cisco's rapid PVST Plus, which will probably run, and that's the version we'll be focusing on today. It's also the version that is mentioned in the official exam topic. Also, all of the information here applies to the standard 802.1W, but that's not the version that runs it. The good news is, since you already understand classic STP and PVST Plus, it will be much easier to learn rapid STP, rapid PVST, by comparing it to the previous version. Let's get started. Before getting into the details, here is Cisco's summary of RSTP. RSTP is not a timer-based spanning tree algorithm like 802.1. Therefore, RSTP offers an improvement over the 30 seconds or more that 802.1G takes to move a link to forward. Part of the result is a new bridge-to-bridge handshake method, which allows ports to move directly to forward. So that's the big difference between RSTP and 802.1D. 802.1D uses long timers to determine when it's safe to move to the state, and these timers are quite long to ensure that no loops are accidentally created when a port starts forward. Back when the original STP was created, it was acceptable that a port could take 30 to 50 seconds to react to a change and start forwarding traffic. However, that's no longer the case. So, it uses a handshake mechanism, which allows switches to actively negotiate with other switches and move ports immediately to the forwarding state if appropriate. Okay, now I will introduce some of the specifics of RSTP. By the way, I will probably say RSTP sometimes and rapid PVST Plus other times. Really, I'm talking about the same thing. Cisco's rapid PVST Plus operates the same as RSTP, but with the addition of a separate instance for each VLAN. So I'll use the two terms interchangeably. Let's summarize some similarities between STP and RSTP. First of all, RSTP serves the same purpose as STP, blocking specific ports to prevent layer 2 loops. RSTP elects a root bridge with the same rules as STP. I'm sure you know it by now. The switch with the lowest bridge ID becomes the root. It also elects root ports with the same rules as STP. So the interface with the lowest root cost becomes root port with the same tiebreaker, neighbor bridge ID, and then neighbor port ID. We studied this in day 20's video, our first video on STP. RSTP elects a designated port with the same rules as STP. So the interface on the switch with the lowest root cost will become designated, and the interface on the other switch will be non-designated. If there is a tie, the switch with the lowest bridge ID will set its interface with the same rules as STP. So the interface on the switch with the lowest root cost will become designated, and the interface on the other switch will be non-designated. If there is a tie, the switch with the lowest bridge ID will set its interface to designated. Cisco has said that RSTP isn't a revolution, just an evolution. It made some major improvements to speed up STP, but it didn't change it completely, as you can see here. Now let's look at some of the differences of STP and RSTP. First up, port costs were updated for rapid spanning. Classic spanning defines port speeds up to 10 gigabits per second, and I believe port speeds faster than this are all given a cost of 1. To accommodate for faster speeds, RSTP's cost values were expanded. 2 million for 10 megabits per second, 200,000 for 100 megabits per second, 20,000 for 1 gigabit per second, 2,000 for 10 gigabits per second, 200 for 100 gigabits per second, and 20 for 1 terabit per second. Beyond this, a 10 terabit per second interface would have a cost of 2. Use the flash drive to remember the port costs for both classic and rapid STP. Here's a slide from day 21, the different port states of classic spanning tree protocol. Hopefully you remember these. Which ones send and receive BPDUs, which one forwards. Traffic, and which ones learn MAC addresses. However, rapid spanning simplifies the port states, reducing them to just 3 by combining 3 of these states into 1. The 3 states that are combined into 1 are blocking, listening, and disabled. Actually, a more accurate way is to say that the blocking and disabled port states were combined into 1, and the listening state is simply not used. So the listening state is gone. Blocking and disabled states have become the discarding state. If a port is administratively disabled, meaning it has a shutdown command to it, it will be in a discarding state in RSTP. This was previously the disabled state. If a port is enabled, blocking traffic to prevent layer 2 loops, it is also in a discarding state. This was previously the blocking state. Next, how about port roles? Remember, the 3 original port roles are root, designated, and non-designated. Root port role remains unchanged in RSTP. The port that is closest to the root bridge becomes the root port for the switch. Of course, closest, port with the lowest root cost. Also, the root bridge is the only switch that doesn't have a root port. So these points are the same as what you already learned about classic spanning trees. The designated port role also remains in RSTP. The port on a segment is another name for a collision domain that sends the best BPDU is that segment's designated port. And there can only be one designated port per segment. The other port on the segment is either a root port or a non-designated port in classic spanning. However, non-designated port role was divided into 2 separate roles in RSTP. Those are the alternate port role and the backup port. Let's break down those 2 roles. First up, the alternate port role. RSTP alternate port role is a discarding port that receives a superior BPDU from another switch. This is the same as what you've already learned about blocking ports in classic STP. In our little topology down here, which one is the root bridge? When BPDUs are sent to this switch 3 receives a superior BPDU from switch 2. Superior which I think switch 2 is lower than switch 2. So switch 2's interface is designated, and switch 3's is an alternate port. An alternate port basically functions as a backup to the root. If the root port fails, the switch can immediately move its best alternate port forward as the new root port. Switch 3's root port fails. Its alternate port is ready to immediately become the root port. No transition. This immediate move to forwarding state functions like a classic STP optional feature called uplink fast. Because it is built into RSTP, you do not need to activate uplink fast using RSTP or PVST. We did look at uplink fast in the previous videos, It's not mentioned in the exam topics, but try to remember that its functions are built into rapid span. You might get asked about that. Uplink fast is one STP optional feature that was incorporated into our STP. Since I just mentioned one, I'd like to briefly explain one more that was incorporated into ours, since I did three restraints. First up, the alternate. The RSTP alternate port is a discarding port that receives a superior BPDU from another switch. This is the same as what we've already learned about blocking ports in classic STP. In our little topology here, switch 1 is the root bridge. When BPDUs are sent in this topology, switch 3 receives a superior BPDU from switch 2. It's superior because the bridge ID is lower than switch 2. Switch 2's interface is designated, switch 3's is an alternate port. An alternate port basically functions as a backup to the root port. If the root port fails, the switch can immediately move its best alternate port to forward as the new root port. If switch 3's root port fails, its alternate port is ready to immediately become the root port, with no transitional state. This immediate move to forwarding state functions like a classic STP optional feature called uplink fast. Because it is built into RSTP, you do not need to activate uplink fast when using RSTP or rapid PVST. We didn't look at uplink fast in the previous video. It's not mentioned in the exam topics list, but try to remember that its functions are built into rapid spanning tree. You might get asked about that on the exam. So, uplink fast is one STP optional feature that was incorporated into RSTP. Since I just mentioned one, I'd like to briefly explain one more that was incorporated into RSTP. Neither of these are on the exam topics list, so you don't have to learn them in depth, but just be aware of their general functionality, because they are part of RSTP. One more STP optional feature that was built into RSTP is backbone fast. Let's say switch 2's root port is cut off, so it stops receiving BPDUs from the root bridge. It will then assume it is the root bridge, so it will send its own BPDUs to switch 3. However, switch 3 is now receiving BPDUs from both switch 1 and switch 2, but switch 2's BPDUs are in say that was the built into RSTP is backbone fast. Let's say switch 2's root port is cut off, so it stops receiving BPDUs from the root bridge. It will then assume it is the root bridge, so it will send its own BPDUs to switch 3. However, switch 3 is now receiving BPDUs from both switch 1 and switch 2, but switch 2's BPDUs are inferior. They have a higher bridge ID. Without this backbone fast functionality, switch 3 would just ignore these BPDUs from switch 2 until its non-designated port, in classic STP, finally changes to a forwarding state, forwards the superior BPDUs to switch 2, then accepts switch 1 as its root bridge again. However, backbone fast allows switch 3 to expire the max age timer of that interface, rapidly forward, then accepts switch 1 as its root bridge again. However, backbone fast allows switch 3 to expire the max age timer of that interface, rapidly forward the superior BPDU. This functionality is built into RSTP, so it does not need to be configured. So that's a very basic explanation of backbone. Let's look at a quick summary. Uplink fast and backbone fast are two optional features in classic STP. They must be configured to operate on the switch, but it's not necessary to know how to do so for the CCNA. Both features are built into RSTP, so if the switch is running RSTP, you do not have to configure. They operate by default on all switches running RSTP. Finally, you do not need to have a detailed understanding of them for the CCNA. I recommend that you know their names and their basic purpose, which is to help blocking or discarding ports move to forwarding without delay. If you want to learn more, do a Google search for spanning tree uplink fast. or spanning tree backbone factor. Learning how to effectively search on Google for information is an essential part of being a good network engineer. We Google things all the time in our daily work, and you can bet I Google things a lot when preparing this video. So, if you ever want to learn more about a topic in one of these, take the chance to improve your Google skills. Try to search for some good resources. Okay, after that little detour, let's look at the last port role in RSTP. We just saw the alternate port role, which is just like the non-designated port role we saw in the previous lecture. Next up, let's look at the backup port role. RSTP backup port role is a discarding port that receives a superior BPDU from another interface on the same switch. This only happens when two interfaces are connected to the same collision domain via a hub. Notice that there is now an Ethernet hub connected between switch 2 and switch 3. When BPDUs are sent in this network, this only happens to you. Next up, let's look at the backup port role. RSTP backup port role is a discarding port that receives a superior BPDU from another interface on the same switch. This only happens when two interfaces are connected to the same collision domain via a hub. Notice that there is now an Ethernet hub connected between switch 2 and switch 3. When BPDUs are sent in this network, BPDU sent out of switch 2's designated port is flooded by the hub. Here, it received that same BPDU on a different interface. That's why this interface is a backup, not an alternate. However, I've already told you that hubs are not used in modern, so you will probably not encounter an RSTP backup. It's still something you should know. RSTP backup ports function as a backup for a designated. Switch 2's designated port fails. Its backup port immediately begins forwarding traffic as a designated. Now, as for how the switch chooses which port will be the designated port and which will be the backup port, the interface with the lowest port ID will be selected as the designated port. Other will be the backup. Before moving on, let's try out a quiz test. Identify the root bridge and the RSTP port role of each switch interface in this network. By the way, the hub doesn't participate in spanning. Hubs aren't sophisticated enough to use spanning.
This one will be the root bridge and G00, G01 on switch 1 is the designated port. This is video route. Next one, 02 on videos.
So it just floods all frames it receives. Okay, pause the video here to find the answer. Okay, let's check the answer. The root bridge is switch 1, because all switches have the same priority, and switch 1 has the lowest MAC effort. It's selected as the its interfaces. These are designated ports. These are the root ports for each. Switch 2 and switch 3's root ports are obvious. They have the lowest root. How about switch 4's root? The hub doesn't participate in STP, so it doesn't add any cost. So why did switch 4 choose G01 over G0? It's because the neighbor bridge ID is lower than G01. Because switch 2 has lower MAC address. Switch 2's G01 connected to switch 4's G01 becomes designated. Now, how about the connection between switch 3 and switch 4? First of all, which switch sets its interface to designated? Well, switch 3 has a lower root cost, so one of its interfaces will be the designated port. Which one? P00 has the lower port rank, so it will be the designated port in this collision domain. How about switch 3's G01 and switch 4's G00? Switch 3's G01 receives the superior BPD with the lower port ID from the same source, so it's a backup. Switch 3's G01 receives the superior BPD with the lower port ID from the same source, so it's a backup port. Switch 4's G00 receives the superior BPD from a different source, so it is an alternate port. Okay, those are the answers. Hopefully you answered correctly. If not, don't worry. There will be more practice at the end of the video. Let's take a quick look at the CLI. I'm on switch 3 here. As I showed you in the last video, there are 3 STP modes you can run on a switch: MST, PVST, and Rapid PVST. Rapid PVST is the default on modern Cisco switches, so you probably won't have to use this command. But I entered spanning tree mode Rapid PVST to make sure it runs in Rapid PVST mode. Then I used show spanning tree to confirm. Notice that it says spanning tree enabled protocol RST. Previously, when we were using classic STP, it said IEEE. Now it says RST. Although it says RST, this is in fact Cisco's Rapid PVST Plus run. Now, the only other difference I want to point out is this. As shown in the network diagram, switch 3's G01 interface has the backup one. The status is still listed as BLK for block, although this state is actually called discarding Rapid STP. I use the show spanning tree command, switch 4 also. As in the network diagram, switch 4's G00 interface is an alternate port. Once again, this command lists the status as blocking, but remember, the Rapid STP name for this state is actually discard. Just one note about running different STP versions. Rapid STP is compatible with classic STP. Interface, or interfaces, on the Rapid STP enabled switch connected to the classic STP switch will operate in classic STP mode with the same timers, same blocking to listening to learning to forwarding state process. So if you have a really old switch that doesn't run Rapid STP, you can still use it in a network of Rapid STP enabled switches. They will adjust the operation of those specific interfaces to match this forward switch. So in our network diagram, if switch 4 was running classic STP, switch 2 and switch 3 will make these interfaces run in classic STP. But their interfaces connected to switch 1 will remain in Rapid STP. Next, let's look at the updated BPDU for RST. Here on the left is the classic STP BPDU for comparison. I made it smaller so you can see the Rapid STP BPDU better. Most of the BPDU remains unchanged, but there are some differences you should. As I mentioned last time, you don't need to memorize the BPDU. That's more depth than is required for the C. You just need to know a few aspects of it, what kinds of things are included in it. The first difference to know between these two BPDUs Notice that the RSTP BPD has a protocol version of 2, whereas classic STP has a version of 6. Remember these version numbers for the exam. 0 for classic STP, 2 for rapid STP. Rapid STP BPD also has a BPDU type of 2. Now, the next difference is here. The classic STP BPDU uses only 2 bits of the BPDU flags, first bit and the 8th bit. However, the rapid STP uses all 8 bits. These flags are used in the negotiation process that allows rapid STP to converge much faster than classic STP. That's all you really need to know about the rapid STP BPDU itself, compared to the previous version. But there is one more major difference. In classic STP, only the root bridge originated BPDU. The other switches just forwarded the BPDUs they received. In rapid STP, all switches originate and send their own BPDUs from their designated port. Let's go through a few other differences. First, as I just said, all switches running rapid STP send their own BPDU. Switches also aid the BPDU information much more quickly. In classic STP, a switch waits 10 hello intervals, which is 20 seconds. In rapid STP, a switch considers a neighbor lost if it misses 3 BPDU, which is 6 seconds. It will then flush, meaning delete, all MAC addresses learned on that interface. Why does it do this? Because the neighbor is down, it knows it can't reach anything through that interface. For example, in this network, traffic from PC1 to PC2 usually follows this path. But what if this connection is cut off? This switch will think, I can't reach this neighbor anymore. I'll clear all entries for this interface from my MAC table, and its other interface will become the root port. Then, if PC1 wants to send traffic to PC2 again, it will go through the normal process of flooding until it learns the MAC address on this new interface, and traffic will now follow this path. That's just a quick look at how topology changes are handled in rapid STP. There is a lot of depth that we could go into about this, but it's not necessary for the CCNA. If you want to go on to get your CCNP and CCIE, you'll definitely have to study these processes more in depth. Before I summarize everything and move on to the quiz, there is one more concept of RSTP you should know, the RSTP link types. RSTP distinguishes between 3 different links. First type is edge. Edge port is a port that is connected to an end host. It moves directly to forwarding without negotiation. Does this sound similar? It sounds like port fast. Well, the port fast functionality was built into RSTP. So there's another STP optional feature built into RSTP by default. Uplink fast, backbone fast, now port fast. The next link type is point-to-point. This is used for direct connections between 2 switches. However, there is one more type, although it is one you probably won't use it. That type is shared. This is a connection to a hub, like we saw earlier in the video. These connections must operate in half duplex to avoid collisions. Don't confuse these link types with the spanning tree port roles or port states. Basically, the point-to-point and shared link types just distinguish between full and half duplex connections. And the edge type is a port that uses port fast. Okay, let's take a Quick look at each type. As I said, edge ports are connected to end hosts. Because there is no risk of creating a loop, they can move straight to the forwarding state without the negotiation process. They function like a classic STP port with port fast enabled. In fact, you configure an edge port simply by enabling port fast on the port. Here's the command, just like in classic STP. So really, port fast and an RSTP edge port are the same thing. In this network down here, which ports should be configured as edge ports? Pause the video if you want to think about it. Got the answer? All of these ports, the ones connected to the PCs, should be configured as edge ports. Next up, point to point. These ports connect directly to another switch. Because they connect to a switch, not a hub, they function in full duplex mode. You don't need to configure the interface as point to point. The switch should be able to detect that it is connected directly to another switch and will operate in full duplex as a point-to-point port. However, if you want to explicitly configure the point-to-point link type, use this command. Spanning tree link type point-to-point. So, which connections in the diagram are point-to-point? Pause the video to think about it. Did you find the answer? It's these three, the direct connections between two switches. Finally, shared ports connect to a hub. Due to the nature of hubs and the likelihood of collisions, these links must function in half duplex. Once again, you don't need to configure the interface in shared mode. Switch will detect. However, to manually configure it, use this command. Spanning tree link type share. Although you should be aware of this type of RSTP link, as I already said, you will probably never actually see this link type in real network. Hubs are old technology that have been fully replaced by switches. So, which connections in the diagram are shared connections? I think the answer is fairly obvious. All of the remaining, which are connected to the hub. So, these connections here are shared links. Before moving on to the quiz, let's summarize what we covered today. First up, we compared the different versions of STP. The classic STP is 802.1d. Cisco's upgrade is PVST+, which runs a separate spanning tree instance for each view. Then the next standard version is 802.1w, Rapid Spanning Tree Protocol. Cisco's version of this is Rapid PVST+, which again runs a separate instance for each VLAN. Then there is one more industry standard, multiple spanning, with which you can create multiple spanning tree instances and group multiple VLANs within each instance. There is no Cisco version of MSTP. Cisco switches run the industry standard protocol. Then we looked at Rapid PVST+. Actually, all of this is Rapid Kingston. This to rapidly moves runs a classic STP. First up, we compared the different versions of STP. The classic STP is 802.1d. Cisco's upgrade is PVST+, which runs a separate spanning tree instance for each VLAN. Then the next standard version is 802.1w, Rapid Spanning Tree Protocol. Cisco's version of this is Rapid PVST+, which again runs a separate instance for each VLAN. Then there is one more industry standard, multiple spanning, with which you can create multiple spanning tree instances and group multiple VLANs within each instance. There is no Cisco version of MSTP. Cisco switches run the industry standard protocol. Then we looked at Rapid PVST+. But actually, all of the information we looked at applies to the industry standard RSTP as well. RSTP is an evolution of classic STP. Instead of using timers, it uses a negotiation process to allow it to rapidly move the necessary ports to a forwarding state and rapidly adjust to changes in the network topology. I didn't mention any specifics of the negotiation process. That level of depth is not necessary for the CCNA. I told you about the port states in our. There are only three: the starting, learning, and boredom. The listening state was deemed unnecessary, and in fact, the learning state is often skipped due to the built-in features of rapid STP, like uplink fast and backbone. We talked about RSTP port roles. There are 4. Root and designated ports are the same, but RSTP distinguishes between 2 types of ports in the discarding state. Alternate ports are discarding ports, which receive a superior BPDU from another. This is the usual case. Backup ports, on the other hand, receive a superior BPDU from an interface on the same switch. This only occurs if connected to a hub, which is a situation you'll probably never encounter. Hubs are no longer used. I also mentioned some optional features of classic STP, which were built into RSTP. First, I showed you uplink fast and backbone, but port fast is also built in through the edge port function. Although you have to note port fast for the CCNA, you don't need a detailed understanding of uplink fast and backbone. I briefly showed you the RSTP BPDU. Just remember that the protocol version in an RSTP BPDU is 2, whereas in classic STP it's 0. Also, remember the important point that in RSTP, all switches send BPDU, not just the root bridge. Finally, I showed you the RSTP link types. Edge ports are connected to end hosts, and you configure an edge port by enabling port fast on the interface. Point-to-point means it is connected directly to another switch. Shared means it is connected to a hub. Must use have-to. As I said before, hubs aren't really used anymore, so you probably won't see a shared link type in any real network. Okay, let's move on to the quiz. After a few quiz questions, let's take a look at my favorite set of practice exams for the CCNA, Boson Software's XSIM. Back before I started this YouTube channel, I used Boson XSIM to prepare for my CCNA and CCNP exam, and I really think XSIM played a big role in me passing all of my exams on the questions are very similar to the questions on the real CCNA exam, and Boson gives in-depth explanations which really help deepen your understanding of the topic. Okay, now continuing on from quiz question 1, which we did earlier in the video, let's go to quiz question 2. Which IEEE 802.1d optional built into IEEE 802.1w standard
Yes.
and allow ports to move rapidly to the port path. C. BPDU guard storage
Fast, uplink fast, backbone fast.
and fast. A. Root guard, C. BPEU guard, F. Loop guard are spanning tree optional, but they are not features built into RSTP that allow ports to move rapidly forward in state. Root fast, not a real STP optional. B. Port fast allows edge ports connected to end hosts rapidly to the forwarding state. D. Uplink fast. E. Backbone fast allow ports to move rapidly to forwarding in certain cases of interface failure. Let's go to question 3. Want to configure an 802.1W edge port so that hosts connected to the interface failure allow ports to move rapidly to forwarding in certain cases of interface failure. Let's go to question. Want to configure an 802.1W edge port so that hosts connected to the interface can begin sending traffic over the network immediately. B. Link type port fast. Got your answer.
Yes.
The answer is D. Spanning tree port fast. Although edge is a link type in RSTP, you don't use the spanning tree link type command to configure it, and the command doesn't even include the word edge. To configure an RSTP edge port, simply configure port fast on the interface with the command spanning tree port. Okay, let's do one more quiz question. Identify the root bridge in this network. What is the RSTP port role of each switch? What is the appropriate RSTP link type of each connection between devices? This is a pretty long question. I recommend taking a screenshot and writing the port roles and link types on the screen so you can remember everything. Pause the video now to find the answer.
point to point, point to point, point to point, and here.
Pause the video now to find the answer. Okay, hopefully you solved it. The root bridge is switch 1. It has the lowest priority. How about all of the root ports? Here they are. Switch 4 if it's a G00 interface, because switch 3 has a lower bridge ID than switch 2, even though they have the same root cost, because the hub doesn't add bridge ID than switch 2. G00 interface, because switch 3 has a lower bridge ID than switch 2. All of the root port bridge is switch 1. It has the lowest. Priority. How about all of the root ports for the network? Here they are. Switch 4 if it's a G00 interface, because switch 3 has lower bridge ID than switch 2. Even though they have the same root cost, because the hub doesn't add any.
Hey! In.
These are the designated. Part with an interface on switch 2 and not switch 4 select designated because switch 2 has the lower root path. Finally, the discarding interface. Notice that there is one back. Okay. Switch 2's G02 interface. This is because it receives a superior BPDU from an interface on the same switch, the G01 interface. Now, how about the link types? All of these ports connected to end hosts should be edge ports. All of these full duplex connections between switches are point-to-point links, and these half-duplex connections with hub shared links. If you had trouble with this, you should review the spanning tree videos, including this one. And if you still don't understand, feel free to ask a question in the comments. Okay, now let's check out a question from Boson. XSIM, CCNA. The question that mentions edge port.
Which of information in the forwarding
Something you just learned about. And oops, it's not a feature places. You should know that you're doing it. Okay, and we are correct. So you can see it gives quite a detailed explanation. This is really the great thing about Boson XSIM, that they're practicing. Not only does it tell you why PortFest is the correct answer, but here it gives you a brief summary of each of these other options. Loop guard, group guard, BPDU guard, and BPDU filter. So you can know why they are not the correct. After all that, gives references to the official. Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download this practice lab, link in the description, and try it out yourself in packet tracing. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like packet tracing, but it's even better. And it includes all of these guided labs, not only help you get hands-on practice, configuring and troubleshooting, but also deepen your understanding of the exam topic. I used it myself when studying for my certificate, so I feel confident about recommending it to all of you. Watch until the end of this video. We'll take a quick look at a lab from NetSim. If you want to get your own copy of NetSim, please follow the link in the video description. In this lab, we'll analyze rapid spanning tree protocol with a little bit of configuration. I hope this lab will help you test and improve your understanding of the concepts of RSTP, such as the different port rules and link types. Let's get right into it with step 1. First, we are asked which switch is the root bridge. Each switch has a priority of 32,768, which is 32,768 plus 1. So these numbers are all for VLAN 1. We will only be dealing with one VLAN. Of course, if there are multiple VLANs, the RSTP topology would probably be different in each VLAN, because we can choose a different root bridge for each VLAN. So because each switch has the same priority, we have to compare MAC addresses. Switch 1's MAC address is the lowest. Both switch 1's and switch 3's MAC addresses start with 000. But the next digit in switch 1's is 5, and in switch 3's it's C, which is equivalent to 12. So switch 1's is the lowest, and it's the root bridge. Now let's examine the port role and state of each interface on switch 1 and see what's different than what we have learned so far about the group. Enter privileged exec mode with enable. Next, show spanning Okay, F02, F0 state of each interface on switch 1, and see what's different than what we have learned so far about the group. Enter privileged exec mode with enable. Next, show spanning. Okay, F0.
This is British. Alah.
Goblok. Tingling.
Tapi dia pakai lens lens.
Guys.
Yang nggak pernah dapat buku. Namanya paling nggak tahu namanya.
Bisa nggak pernah ngepopi itu ya?
Nggak pernah. Pertama pun nggak dapat deh. Gitu. Mau ke tangan. Yang warna merah. Dorong aja. Offline. Ele deu offline. Tapi gila, Ben. Warna. Iya. Oh, gila, Ben. Nomor 20 tablet. Yes. Lupa. Apa ya? Satu. Gede aja ini. Match 408 bener. Memang bener-bener doang. Kalian apa itu? Didoain.
Two, X01 and X024 are designated ports in a forwarding state, and X03 is a backup port in a discard, although it's written as blocking the output of this command. I'm going to take these labels I've made, place them over the interface. So what is different than what we have learned about the root bridge in the course? Well, I have repeated multiple times that all interfaces on the root bridge are designated ports. However, in this case, X03 is a backup port. So actually, the more accurate statement is that the root bridge has a designated port in each collision domain it is connected to. In modern networks, ports aren't really used. So we usually just say that all interfaces are designated. However, if the root bridge has two interfaces in the same collision domain, because they both connect to this hub, the rule that there must be only one designated port per collision domain applies, and the other interface will be a backup port. If this was classic spanning tree, X03 would be a non-designated. So that's step one. Although I have said many times that every interface on the root bridge is designated, in this case, X03 isn't, because it's in the same collision domain as X02. Step 2 asks us to determine the port role and state of each remaining switch interface without using the CLI. First, let's place the root port. Switch 2's root port is X01 with a root port of 19. How about switch 3's root port?
Now I don't wanna fight this. Which is the root bridge? Tujuh sembilan, sembilan, dua tujuh lima, lima lima delapan.
Each switch has a priority of 32,760, which is 32,768 plus 1. So these numbers are all for VLAN 1. We will only be dealing with this. Of course, if there are multiple VLANs, the RSTP topology would probably be different in each VLAN, because we can use a different root bridge, etc. for each VLAN. So because each switch has the same priority, etc. for each VLAN. So because each switch has the same priority, we have to compare MAC address. Switch 1's MAC address is the lowest. Both switch 1's and switch 3's MAC addresses start with 000. But the next digit in switch 1's is 5, and in switch 3's it's C, which is equivalent to 12. So switch 1's is the lowest, and it's the root bridge. Now let's examine the port role and state of each interface on switch 1, and see what's different.
Tembok udah susah-susah di-upgrade, kena gempa hancur. Gempa. Tembok berapa aja kayaknya ya anjir tampilan doang. Waduh beli naga tuh. Penir lagi. 9 tuh. 9 kan? Jangan beda harga. Dan sekarang saja bulan kembali ke lainnya. Lampu gak main aja mesti kasih penghargaan anjing jagonya. Ini kita 3 anet kan. SP-nya kan. 3 tricks gitu. Gue tuh pakai itu. Kedua. Kalau apa gue yang pakai itu nih? Apa enggak? Gue mau bete. Beatrix. Kalau 5 kalah 5 buka ini. 5 itu wasting. Tapi kita bukan kalah.
And what we have learned so far over the root bridge are designated
Posting baru di sini. daerah yang aja. Ya bagus ya. Kalau dia dari awal dia aktifin. Kalau dia gagal di awal, kan mencoba kita bakal PD, bakal operasi tarik box. Memang PD. Kalau begini, tahan terus. Adrenalin tuh di atas terus. Itu obat nyamuk sih banget cok sampai ayu putih kayak putih. Nyamuk gerak.
Iyalah gak ngaruh aja. Kita nih yang mati.
Nyamuk sih ada jempol cok.
Anjing.
Nyamuk sisa tulang ya sebelah gua.
Gila-gila. Kayak jarum lagi. Gatal dong. Skill. Nah, jadi kedua. Net pasti.
Tidak. X. On defense.
Anjing.
Bangga pertama apa? Toler ya lo. Lu mau apa enggak? Empat ya lu ya? Tidur aja guys. Tidur kayaknya ya. Oish.
Terus
Namanya sekarang Ini yang kayak gini-gini nih.
Anjing lah.
Mana? Punya diturut di sana ada QB. QB-nya itu loh, Ben.
Iya.
Reports. However, first let's place the reports. Switch 2's root port is F01 with the root at any spanning tree cost. How about switch 3's root port? Does this hub add any spanning tree cost to the BPDU? No, it doesn't. So switch 3's F02 also has a cost of 19, making it the root port of switch 3. Switch 4's interfaces have the same root cost. So which neighbor has the lowest bridge ID? It's switch 3, because its MAC address is lower. So switch 4's F01 interface, it's switch 3 root cost. So switch 4's interfaces have the same,
Shotgun gue nembak angin.
making it the root port of switch 3. Switch 4's interfaces have the same root cost. So which neighbor has the lowest bridge ID? It's switch 3, because its MAC address is lower. So switch 4's F01 interface is its root port. Next up, the designated port. Switch 3's F01 across from switch 4's root port is designated. Now, for the gigabit Ethernet link between switch 2 and switch 3, which side will be designated? They both have the same root cost, 19. But switch 3 has the lower bridge ID. So its G01 will be the designated port. How about between switch 2 and switch 4? In this case, switch 2 has the lower root cost.
Buset
So
lah.
its
Nafsu banget, cok. Pliker-pliker dia.
F02 will be designated. So switch 2's G01 and switch 4's F02 will be alternate ports in a discarding state.
Penendang
These ports connected to the end hosts should all be designated ports, by the way. I won't bother labeling them. Now let's quickly confirm on each switch. We already saw switch 1, so I'll go on switch 2. Enable. Show spanning. F01 is the root. F02 is designated.
Ngapain banget?
G01 is alternate. And F023 and 24 are designated.
Yeah.
Looks good. Next, I'll check on switch 3. Enable. Show spanning tree. F02 is the root port. G01 is designated, and so is F01. F024, connected to the PC, is also designated, just as we expected. Finally, I'll go on switch 4. Enable. Show spanning tree. F01 is the root port, F02 is alternate, and F024 is designated. Okay, looks like we got it.
Langsung ada shotgun baru masuk rumput ya.
Finally, let's manually configure the appropriate RSTP link type on each interface. The one I really want to show is switch 1's F024. So let's quickly go through the others, starting here on switch 4 first. Conf T. Let's configure F01 and 2 as point-to-point links, because they are directly connected to switches.
Apa sih ini ya? Males banget gue setiap ketemu gue ketemu di all in ya.
They are operating in full duplex mode. Interface range F01 to 2. Spanning tree link type, point to point. Next, I'll configure F024 as an edge port by enabling port fast. Interface F024. Spanning tree port fast. Now let's check. Do show spanning tree. Okay, F01 and 2 are point to point, which is correct. Actually, they were already point to point by default. I just wanted to practice the manual configuration. Now, what's up with F024? It still has the default type of point to point. Well, this is something I didn't explain in the lecture. Edge ports connected to an end host like this will still be point to point links if they're using full duplex. There is no hub here. Therefore, the link is full duplex, so this is a point-to-point link. However, it's also an edge port. It doesn't work in Packet Tracer, but if you enter the spanning tree port fast command on a port on a real switch, it will display both edge and point-to-point here in the type section. Point-to-point means it is full duplex. Edge means port fast is enabled. So it's both an edge port and a point-to-point port. Okay, let's do switch 3. F01 and G01 should be point-to-point. However, F02 is connected to a hub. It should be a shared port. Actually, let's check before we configure it. Show spanning tree. As you can see, the switch automatically sets it to the correct port type. So really, the only one we have to configure is F024, because port fast won't be enabled by default. We have to configure it. 02 is connected to a hub. It should be a shared port. Actually, let's check before we configure it. Show spanning tree. As you can see, the switch automatically sets it to the correct port type. So really, the only one we have to configure is F024, because port fast won't be enabled by default. For the sake of time, let's just do that. T, interface F024. Spanning tree port fast. Okay, next let's go on switch 2. Let's check first again. All ports are using full duplex, so they should all be point-to-point by default. Show spanning tree. Indeed, all ports are point. Again, for time, I'll just enable port fast on F023 and 24.
Sempak di mana-mana nih orang. Apa itu?
Janda ini nilai doang kerjaannya.
Gimana tuh dari belakang tuh hero aja? Dari situ tuh muncul tuh dari lubang tai itu.
Ulti ini. Temu-temu di hidup cepet ya. Pernah ditemuin di jalan tuh kalau ya ada ini. Yang di ini loh. Yang pendidikan lupa tuh.
Let's check.
Aduh, clicker dia. Coba sih pin kayaknya. Coba banget pin kayaknya jadi jalur gini. Anjir. Jangan aja, Cok. Kita harus seperti di atas loh jadi. Tuh, sampai situ ini. Tuh, mampus lu. Gila lagian. Matinya banyak juga ya. Terus kayak bisa. Kenceng banget, Cok. Pelari semua.
Firenze? Pizza?
Ben, lagi Ben.
Just do that. Conf T, interface F024. Spanning tree port fast. Okay, next let's go on switch 2. Let's check first again. All ports are using full duplex, so they should all be point-to-point by default. Show spanning tree. Indeed, all ports are point-to-point. Again, for time, I'll just enable port fast on F023 and 24. Conf T, interface range, F023 to 24. Spanning tree, port fast. Okay, finally switch 1. In this case, it has 3 ports connected to a hub. These should all be shared by default. Only F01 should be point-to-point. Let's check. Show spanning tree. As expected, F02, 3, and 24 are shared. So F024 is connected to a hub, but there are end hosts connected to the hub. Should this be an edge port? The answer is yes. The hub basically doesn't exist in terms of spanning tree. It's different than if it were connected to a switch here. So F024 is an edge port and a shared port, just like I explained with the edge point-to-point links connected to end hosts on the other switches. Let's configure it. Conf T, interface F024. Spanning tree port fast. And let's check. Do show spanning tree. Okay, so just like before, in Packet Tracer it doesn't display here, but on a real switch it will display both edge and shared here in the type column for F024. Point-to-point and shared distinguish between full and half duplex, but either can be an edge port as well. Okay, that's all for this lab. I hope this helped you get familiar with some concepts of RSTP. Next, let's take a look at a lab in Boson NetSim. Okay, for today's Boson NetSim lab preview, we're once again doing a lab from NetSim for CCNP Encore. I said this before, but that's because spanning tree configuration isn't actually in the CCNA exam topics list.